Webinar. It's my privilege to introduce today's distinguished speaker, Mr. Shankar Sharma, who is a seasoned power and climate policy analyst with over 44 years of professional experience across India, New Zealand, and Australia. Mr. Sharma holds a bachelor degree in electrical engineering from University of Mysore and a postgraduate diploma in technology management from Deakin University, Australia. His career has spanned multiple domains of the electric power sector, that is generation, transmission, distribution, and asset management planning. Beyond his technical expertise, Mr. Sharma is deeply engaged in policy advocacy and climate action. He has authored 2 books on the electricity sector, contributed to reports for the Karnataka State Pollution Control Board and Greenpeace India, and written numerous thought-provoking articles on energy reforms and sustainability. Currently, he collaborates with civil society organizations promoting reforms in the power sector and raising awareness on environmental issues through academic and public lectures. Today, Mr. Sharma will speak on a topic of great relevance to all of us, that is effective application of asset management principles to reduce overall costs and improve reliability in the electric power sector. We are indeed honored to have him with us today, sharing his vast knowledge and insights. Mr. Shankar Sharma, sir.
Thank you very much, Colonel Yadav, Dr. Girish, and Dr. Pai. I thank AM Asset Management Society India for giving me this opportunity to interact with you all professionals. I must say I'm excited because I didn't know that this concept of asset management and the associated issues have taken roots in India. I worked in electricity sector and I was working in India for about 15 years before I went to Australia in 1994. And I came back in 2003, and since then I didn't have any direct hands-on experience with maintenance practices in India. So when I left in 1994, I myself had not heard of anything called as asset management planning. I used to do distribution sector management, but it was very rudimentary sort of manage without any strong policy doctrine, policy requirement, things like that. So I'm excited that this important aspect of the management of any company is taking the deep roots thanks to socially interested professionals like you. I'm very happy to be all with you. I know Dr. Raghuveer Pai very strangely. I didn't know him when I was in India and he was in India. We met each other for the first time in Brisbane. He was there for some time. I was there. Since then, we continue to interact with each other on some issues of common interest. I'm not far away from where he is living, Manipal. I am in the adjacent district of Shumaga. This is my brief background. I always worked in electricity sector at different segments of the sector in different countries and different transmission, distribution, and generation also. I hope my presentation will be of interest to all the participants today. I don't know if I can ask you this team right now. Any of you do have any interaction directly with the electric power sector of the few people here? Okay, I understand none of you have had any direct experience with the power sector, but I strongly believe that the asset management plan, as I want to talk to you about, and as I know, can be easily applicable to any industry with minor changes depending on what are their objectives and all of that. So I will, if you permit me, I will start the presentation slides. Selected tab, should to share WhatsApp. Entire screen. Now, how do I share my PowerPoint presentation screen? Do I have to go there to that screen or what?
Shall I?
PowerPoint. PowerPoint
Shall
presentation is open on my laptop. How do I share it?
you have to go to the button near the leave. Don't hit the leave. Just next to it, there's a share.
Yeah, it's a yes, share, yes, but it's asking me choose what to share with the team Microsoft. What do I do here?
Or should I share it from my laptop?
Yeah, fine. Please do that. If I can also see that, that would be helpful. Yesterday we checked, it was all right, was it not?
Yeah.
Can you please do that, Raghuveer?
Yeah, I've just shared it.
Okay, that's fine. Okay, let's start there. How do I go for this?
I think it's on the screen, hopefully.
Yes, I can see the screen. Anyway, now
We can see
may I start
it.
with that? Can you all see the PowerPoint presentation first page?
Yes, sir. Yes, we are.
Okay.
I mean,
Now
I can see
the
it. So
title I
very
have
visible. Yeah.
yeah, the title I have chosen is Asset Management and Asset Management Plan for an Asset Owner in Power Sector. Basically, because, and I would like to emphasize here that I had only the electricity distribution in my mind when I prepared this, but it can be used for electricity transmission sector also. Okay, next.
So I go to the next slide.
Yeah, please. Okay, now I would like to briefly take you through what is asset management and why is it essential. I'm sure you're all being professionals, you would have known more about this than I can say. But anyway, I would like to say that it is a proven and effective management practice for the management of all the assets of a company in order to secure the best possible results, not only for the owners but for the public as well at lowest overall cost. That's it main it can say I can say that it's a notion about asset management plan. An effective asset management is critical for meeting the overall performance targets of the business, whether it's a public sector or a private sector. Asset management also is critical for the success of the business because it will lead to ensuring that the best possible life cycle costs are ensured, to ensure the lowest possible maintenance expenditure is incurred in a given year, because this will contribute to the profit and loss account of the company or uh, the that entity in a given year. You will appreciate that if the maintenance cost goes up, the revenue, if it remains same, then the overall return will come down. So that is important there. The assets in electricity transmission distribution business are large in number and spread over a large geographical area. This is of importance. This can be compared with like railways. For example, railways is much bigger, and it too has assets all over the country with varieties of equipment there. I tend to compare railways with the electrical power sector, especially if you're looking at a national level sector like National Hydropower Corporation, NTPC, like that, even Power Grid Corporation of India, which has transmission lines all over the country. So asset maintenance and repair, replacement, upgradation cost is a significant portion of a company's capital and operational cost, especially if these assets are spread over a large area. And if you have a varieties of equipment, it may be chemical, electromechanical, hydro, then technologically challenging IT, motor vehicles, buildings, you name any of them, civil engineering projects like tunnels, hydropower plants, they're all very complex and they require a combination of the maintenance practices and a very structured approach involving all sections of the company in order to make it the most beneficial approach to the operation of the company. As you would all appreciate that if these assets are not managed properly, their reliability and efficiency will come down, and hence they are very important. There is a need for ever increasing dependence on the grid quality electricity supply. I'm sure you'll all appreciate that how electricity has become an essential entity in our lives, as an energy sector, especially for continuous processing industries and important sectors like water supply installations, the radio, all India radio, television channels, telecommunications, and all of that. Though many of those assets are being having a backup through their battery energy storage systems in order to get a backup, but still power supply from the grid is very important in many of the areas for many sectors of the country. For example, hospitals. uh, so the unexpected shutdown or at unusual time, there are something called blackouts where a section of the state or the country can completely blacked out. That you can understand how it is important. Few years ago, there was a blackout in North India, and it's supposed to have impacted few hundred millions in our country alone, because we also is a large country with a dense population. So that will be very important. Next slide, please. I wanted to, on the advice of Dr. Raghuveer Pai, my first approach was to have a lot on slides on asset management, but he suggested few diagrams and pictorial representation may be more appealing. I wanted to just take one example of life cycle costing. When I refer to life cycle costing, asset management plan becomes very important in order to minimize the life cycle cost of an equipment, other in addition to improving its reliability and efficiency, and also meeting its performance objectives or targets. So, what is the life cycle costing? I am sure most of you would have heard it, but I would like to start with the planning of the equipment or the system, then the actual design, the construction of that equipment or that entity like a substation or a hydropower plant, then safe operation, say as per the design features, then end of life, where end of life may mean either you rejuvenate, repair, and you reuse it, or safely dispose it off in the environmentally sustainable and least cost option. So these are the general issues. I'm sure you would have appreciated all of that. So in the initial stages of planning and design, the cost related to established may come into picture. Then during the construction period, cost related to use, then cost related to repair, maintenance, all of these will come into picture. And at the end, the final disposal or recycling or repairing. For example, why I want to use this particular terminology is there are certain assets. For example, a nuclear power plant. When we started with nuclear power plant in 1950s, they thought 35, 40 years should be the economic life cycle. Now, many countries are extending the life cycle of that plant up to 60, 70 years. So, if this particular nuclear power plant had been operated and maintained in good condition, there are set of engineers who believe that the power plant can continue to operate safely and reliably for another 20, 30 years. We don't know because we don't have the experience of shutting down a nuclear power plant safely and dispose of all the radiation contaminated parts or assets in it. How to do it? We don't. The humanity did not have enough experience on that. As a matter of fact, I am not aware of any nuclear power plant anywhere in the world which has been retired and safely shut down, and it is completely and safely its waste management have done. We know that there are three major accidents: 3 Mile accident in USA, Chernobyl in Russia, and Fukushima in Japan. But they're all accidents. So society is putting up with the cost. What we are talking about here is safely retiring on our own volition and making it safe and least cost at the time of our choice. Next slide, please. No, what we can ask the question, well, we appreciate what AIM is and all of that. Why are the objective, how it is important to any organization. Now, what does asset management involve? I have listed quite a few points. I'm sure you don't, so nobody need to jot it down. I was told by Dr. Pai that this will be shared with you and you can read that. What these points are basically meant to guide me to state some of the important issues. I have no plan to go through all of that. What we can do is if there is any particular issue you want to discuss, then we can do that at the Q&A session. What is AM is a policy statement. It states as far as the policy is concerned, detailing the maintenance, maintenance philosophy which a company considers the most appropriate for its business environment. But I would like to emphasize here that more than one kind of philosophy may be useful or necessary in a given situation. For example, in a nuclear power plant, a reliability-centered maintenance may be necessary because reliability of the continuous process of the company is very, very important. Same thing with a uh, continuous process industry, reliability is very important. And in case of power supply, power sector, multiple approaches may be required. Some equipment in some part and some part of the day, they are very important. You can't afford to lose them. Some equipment are very high capital cost. You can't afford to lose them. And some equipment can be monitored through condition monitoring. So different options should be used depending on the equipment and our priorities. This asset management plan indicates a company's priorities on the assets, how these assets will be managed. For example, if you consider an airline, international airline, aircrafts are all very costly, so they have to be managed at the highest possible of reliability because they can't afford to fail while they are in the air. So how much expenditure will be incurred in a given period for short term and medium term? This all depends on the policy, company's policy. So as asset management planners and executors, if I assume that we are all in similar role, it will be our role generally to ensure the highest possible efficiency, highest possible reliability, and lowest cost to the company. So this is a multiple object oriented approach. It takes into account corporate objectives. What are the corporate objectives? For example, if there are any regulatory issues for a company, such as, let's say, electricity company, if there are regulatory issues of how it is to manage the local pollution of rivers or soil, then it takes a different approach. We have to put more emphasis because these regulatory issues can lead to a very huge penalty if we transgress the limitations. It also involves specific situation of the company within the industry, whether how is it one of the hundreds or is it a critical company within the industry, whether it is considered to be so for example Navaratna um, groups in the government of India, they have some special approach there. So they are imbibed with a lot of support, financial support. Not all companies may be like that, so we have to take all of them into account. There are always compliance requirements by law, so we have to look at that. There are relevant legislations such as environment and requirement of the regulator himself. So all these things come into picture while preparing the asset management philosophy for a given company. Gentlemen, please tell me, am I going too fast? Am I clearly audible? Shall I slow down?
No, I think you're doing well.
Yeah,
Okay,
no problem.
thank you. I'm in a hurry to involve as many points as possible. That's why I'm trying to do. If there is any problem, please, through the administrator, please raise your hand. I can stop there and come back to your questioning. Then asset management identifies solution to the direct risks to individual assets, such as obsolescence, fire, theft, accidents, then storms, flood, earthquake, etc. All these things have to be taken into account. It aims at systematically documenting all the relevant issues for each of the assets for effective and close monitoring. I would like to put an emphasis on this particular aspect. I worked not only in preparing asset management plan for a hydropower company, a group of hydropower stations in New Zealand, and I was also involved in certain aspects of condition monitoring of the equipment there. I was focusing on generator condition monitoring, the circuit breakers, and transformers. See, these are there are certain equipment which you can monitor through their existing conditions. You can do that without impacting the continuing operation of the equipment. For example, a transformer, you can monitor the condition of the transformer while it is satisfactorily operating. For example, the temperature, the pressure, how much oil is circulating, whether the circulating pumps are operating or not. These things can tell you. And also what we can also do is when there is this time available, you take out a small sample of oil, transformer oil, subject to the condition testing. That will reveal if there are any inherent problem within the transformer. I will show in a subsequent picture how complicated a transformer, a major large size transformers can be. And as you know, that is very critical for satisfactory operation of the power sector. So we can't afford to lose a major transformer. So what we do is, they have already established practices for condition monitoring. This condition monitoring can also tell you how whether the transformer is due for a replacement or a repair, or is it going to fail, or can it continue to be operated at a lower temperature ranges or lower operating ranges. So it can give a lot of information. And many of the equipment in power sector, especially large generators also, the generator also can be, its condition can be monitored while it's still operating. Same thing with circuit breakers. These are all major and heavy costly items in addition to being critical in nature. Same thing with say diesel generators, which is a backup power supply issue and all that. Same thing with a major hydro tunnel which is bringing water to the power station. There are many ways of doing condition monitoring. Since I was in the electrical background, I was focusing on electrical equipment. So condition monitoring also becomes very important in an effective asset management philosophy. Now, what we can do is we can apply this asset management philosophy for each of the major equipment. So what I used to do in Karnataka Electricity Board back in India, there used to be a sort of transformer register. All those transformers which are under my administrative control, we used to have a register. We used to have information, all manufacturing and technical information about the each transformer in each page. Subsequently, that page and additional page to it was recording all the major parameters of the transformers over a period. For example, did it trip on its own? Did it fail? Was it repaired? And yearly, I used to do some online or offline condition monitoring of the transformer without bringing the transformer out of its place. Either you can switch it off, then do the testing of the conditions, or even if it is operating, you can also do that. So I used to do that. So this is called as transformer register. It used to record everything associated with the equipment until it is retired. So I am there in for let's say 2 years. I was in charge of that. I get transferred. Somebody else will come, but he would have the advantage of all the information. Same thing applicable to all equipment. If we maintain the asset management policy in a structured way, I am 100% sure that we can bring down the cost of the company to a considerable extent, especially as the base case may be in India, because I know, and before this session started, I was talking to Colonel Yadav and Dr. Girish and Dr. Pai, and they gave me information that the asset management plan is not practiced in all aspects of our industry in a structured way. So this is a good idea. I would suggest that this professional group may start taking these issues to the outside world, in the company, in the country, even including small and medium enterprises, large industries, and major industries may be taking advice from professionals like you. I don't know, but what I'm worried about is smaller industries, especially the transformers. We get to hear that lot of transformers are failing, and when the major transformer fails in a grid critical location, that plunges the area into darkness. So, and these transformers are very costly equipment, and even if you have a standby transformer to replace it, that replacement process itself may take few days. So cost, so heavy, and so complicated at the location. So effective condition monitoring and applying asset management principles in order to minimize the unscheduled interruptions, or minimize or improve the reliability is very important. It helps to formalize the standardization procedure. This is an important point I want to focus. If you have a good asset management plan, then you, instead of having say hundreds of one class equipment, you can have reduced that. I will give you one example. For example, a large power station, hydro power station or thermal power station, let's say 500 megawatt, 600 megawatt, etc., from a capacity of one generator in a station, which may contain 5 or more generators. Now that is a huge capacity to be handled by one transformer. What they do is, instead of having one single phase transformer for each generator, what they do is they will go for one single phase transformer each phase. Let's say hypothetically, for example, in Sharavati Valley, where I live here nearby, there are 10 hydro generators of 103 megawatt each, and each of them have single phase transformer. And so for 10, there are 30 transformers. What they do is, between 30 transformers, they will have two exactly similar size, similar design, single phase transformer sitting as a spare, ready to be moved into the place anytime. So if you extend this philosophy across the company, for example, similar transformers, similar circuit breakers, similar material. For example, if it is an airline, similar airlines, similar pumping machines, and all that. If you bring standardization into a good quality and maintain a good record of these places, then instead of waiting for the new equipment to come on an order, you can borrow it from other place or use it locally. So standardization also, asset management plan helps in standardization. If you use too many equipment of the same for the same purpose, too many of design, too many companies, too many parameters, then it will not be easy to use one equipment in place of the other. But if you have standardization, for example, let's say in a company like Karnataka Electricity Board, if all the 100 MVA transformer of similar capacity, similar design, similar size, even though they may be from different companies, it's so easy to manage. So if a transformer fails in one village or one power station, if they don't have a spoiled transformer, they can identify through the company level asset management register as to which is the most suitable transformer available elsewhere in the grid, and they can get it instead of waiting for a new transformer to be delivered. Some of these power transformers, once you place order for a new transformer, it takes probably 8, 9, 10 months also to come to the
Okay.
project. So, but if you can borrow it from other parts of
Mm.
the same grid, it's much easier. So that's why standardization becomes very important. Next one, please. And it also reduce complexity and expenditure, because if you have too many equipment to manage, the cost will go up for the company. Yes, next slide, please. Now, how is asset management is practiced? I'm already 33. Uh, Raghuveer, how much more time? Shall I go up to
I
12:45?
Yeah, please.
Okay. Now, sorry, this is such a vast subject, and I have some hands-on experience. I'm very keen to share as many of my experience with you as possible. Now, different companies follow slightly different maintenance approaches, but the overall objective is same. That is to have effective control, and effective control is an important issue here. We must have control over the equipment to the performance level what we look. Even if the cost is not the primary there. For example, if it is a airline, maintaining the aircraft in safe condition is most important than the cost. Of course, cost comes next, and optimal usage of these assets, because as you will appreciate, when you buy, let's say, a huge aircraft or a huge generator running to few crores, optimal utilization throughout its life cycle becomes very important for the fundamentals of the finance of the company. The success of AM policy is strongly linked to the development of involvement of the company's management and the priority. It's very important. I would like to emphasize here that the senior management of any company which is involved in decision making, they must understand the importance of asset management. They should have had some experience in asset management. Only then they will appreciate the importance of asset management. Otherwise, the priority may be different. There may not be enough money dedicated to these maintenance practices. That should be an issue there. In the electricity transmission or distribution company, the person in charge of maintaining the assets will be generally responsible to develop and implement such a policy, of course, in conjunction with the relevant line managers. For example, I was in New Zealand, I was engineer tactical support, giving technical support on a tactical level for a group of companies. I was also in charge of the asset management. So I used to talk to a lot of people. Whenever I used to do the asset management planning for the next year, I used to take about 2, 3 months, starting somewhere in January, December, and go up to March. I used to talk to every line manager, understand what are the issues, looking at in specific sites, a specific equipment, what are their experience, when do they want to put maintenance, scheduled maintenance, and all of that. So the line executive, one person in charge of maintaining a given asset, should be basically responsible for developing and implementing such a policy, but he can get the feedback from the relevant line managers elsewhere. Before arriving at a suitable combination of maintenance philosophy, the process should include discussion, thorough understanding, and various philosophies. For example, I don't know whether I can spend some time explaining them depending on your need. Time-based maintenance. These are the maintenance philosophies I have come across. Just-in-time maintenance or condition-based maintenance, preventive maintenance, total quality maintenance, reliability centered maintenance. These are some of the major maintenance philosophies. I hope you have heard of that. If you any of you want to understand one or two areas there, I can spend some time on that. Hmm. For example, I want to draw your attention to TQM, total quality maintenance. This is known to be a practice which was developed from Japan, where they impact very high importance to the quality. This total quality maintenance talks about applying quality maintenance at every stage of the equipment. Let's say starting from the design. We must understand what is the expectation of that equipment. We must have a clear understanding. There we design that. And while designing the manufacturing facility of that equipment, we must ensure that all our requirement of maintenance practice should go in. The highest quality maintenance, design and manufacturing principles are critically important there. Then how it should operate, what are the issues there? Then how to operate, there should be a specific set of instructions how an equipment should be operated. What are these safety limits? What are the threats? What are the issues? So the operating personnel should also understand that. And that we need to take these operating procedures also into the asset management planning. Then repairs, shutdowns, spares, everything associated with that equipment in a given circumstances in a given company, they all have to be looked into importance there. And just I would, if somebody may be understanding why reliability, what is reliability centered maintenance? The thing that comes up in my mind very quickly are nuclear power plants, the airlines, and the space. For example, if we launch a space satellite, as we have done, ISRO has become a major organization throughout the world. Now you can understand the importance of very high reliability of the spacecraft which is already in space. That's why they used to have almost in all aspects of the spacecraft there is a dual part use. For example, two double solar panels which can ensure continuous supply of electricity. Similarly, so reliability is very high importance in case of a spacecraft or in flying airlines or even nuclear power plant. The reason why reliability is important for a nuclear power plant is if the nuclear power plant suddenly loses its cooling system, because as you know we have only fission type of reactors, they generate a lot of heat, huge amount of heat that has to be continuously evaporated or taken out. Now cooling system becomes very important. If cooling system fails, what happens is this temperature within the reactor runs away, and that may lead to catastrophic shutdown and nuclear explosion. So nuclear power plant generally have more number of transmission lines connected to the power plant because they need electricity. If the electricity within the nuclear power plant fails, there should be electricity available from outside areas. If not for anything, at least to run continuously run the cooling system. So reliability centers become very important. That's just I wanted to bring to your notice. What are they? Of course, I have briefly touched the condition-based maintenance. There is something called time-based maintenance. For example, when will you replace a tire in a vehicle? Is so probably time the manufacturer would have said if you cover say 10,000 kilometers at a given condition, the tire may replace. So of course, the driver or the conductor would be looking at it every day. So that's a time-based maintenance. You can replace that if there is any. For example, in a transformer also there can be annual maintenance where we take out sample to test it, and that's called as annual maintenance. So there is something called just-in-time maintenance or condition-based maintenance. When the condition of an equipment, when it is routinely monitored, it asks you to go for maintenance. You take it out like that. There is also time-based maintenance. Some of these philosophies are not ideally suited for a distribution network of electricity, but TQM is ideal for manufacturing setup. For example, RCM is mostly used in nuclear power plant and aviation industry. Some of the some and even within each of these philosophy, there are certain aspects which you can combine together in order to develop your own management philosophy for a given equipment, depending on the intelligence and the commitment of the concerned person. Okay, anyway, the objective is systematically documenting all the relevant issues. So this is also important, I found. Back in Australia, and probably not in New Zealand, Australia had come there. They are utilizing one software called it's called as what is it? It's a German-based software where all aspects of a given company is operated managed through that software. I have forgotten what is it. Probably one of you may tell that. That software for this entirely management software, including asset management, equipment, purchasing order, the human resource costs, who gets paid when, and all of that, and also most importantly, equipment. For each of the equipment, there is a separate register. That register records everything about the equipment, including the manufacturer's technical details, when it tripped, or when it was replaced, what was the condition, when was the condition, monitor last time, and all of that information. So anybody in the company can look at that and can view that and make use of that. Now, this is total quality management. As I said, it is a complete maintenance of highest possible quality for the entire structure. Focus on customer, employee involvement, process centered. Then integrated system is also there. Strategic and systematic approach of the equipment or the process. Decision making based on facts. This is important. See, as a company, you want to make a decision on either replacement of equipment or a process, or repair it or shut it down. It has to be made on strong and reliable facts. This TQM is also based on that. Then communication from all the concerned, and of course, continuous improvement. See, if you are a manufacturing company, we have to continuously improve upon that. Next slide, please. Next one. I think I'm running out of time. These are some of the equipment, some photographs, how maintenance is being done. Next one. This is a vehicle. Next one, please. This is actually, if you can see, railway traction. I think some of the European countries, how they are doing maintenance. There is a designed vehicle where they can access the high power lines, do that. All the information is there, all the material there. Next one. So how is the aim policy for a given company arrived at? How do we arrive at an asset management plan? This has to be done by talking to all the people. Probably what I found is, for example, a new company, if they want to start with asset management, they can invite an expert like one of you and help them to prepare an initial policy tender. Then over a period of years, that policy document will be implemented, and with the accumulated experience of the local people, they can improve upon that. That's how asset management policy is done. Asset management policy is generally formalized and detailed in a company specific document called asset management plan. This is an asset management plan for a given year. It tells you what. Next one, please. Next year. And this asset management plan should be revised once in 3 or 5 years, depending on your own experience. Next one, please. Next one, please. Next slide.
Yeah.
Okay.
Sorry.
How AIM policy and AMP are related? Obviously, they have to be related to each other. We prepare an asset management policy, keeping the strategic objective of the company. Asset management plan comes from that policy, so they are closely interrelated, and they can feed to each other over a period of time, say 10, 15 years, because of the experience gained within the company. Either asset management policy itself can be tweaked, or asset management plan can also be changed. Next one, please. What are the essential features of asset management plan? There are a lot of issues there. For example, for each category of assets, depending on the network importance and the geographical location, a specific maintenance philosophy can be identified and implemented. So there are a lot of issues there. What does an asset management plan features are there? Next one, please. Now, same thing, continued. There are a lot of issues. We don't have time to go through that. It facilitates opportunity maintenance is also something I want to highlight. For example, some reason a substation is shut down for some other reason, say, not necessarily local. At that time, if you know what is the duration of that outage, then you can immediately take opportunity to undertake any maintenance, because, for example, in a substation, offline maintenance is important. For example, if there is a shutdown for any reason, substation, so all those operational managers can take a decision as to, are there any equipment which need to be urgently repaired, taking benefit of the shutdown. So that's an opportunity maintenance. Then there is judicious utilization of modest resources available to the company. Basically means resource utilization. Responsible persons for individual tasks can be identified. It provides a tool for monitoring operation effectiveness. It is influenced by what is the expectation of the customers, the shareholders, and the regulators. So AMP should be seen as a document which evolves continuously, continuous revision, improvements, and hence should be updated every year. That's what we were doing. Internal experience, the company and the industry knowledge should be used. And of course, it's necessary that we should talk to external experts like you, how improvement can be brought down into the specifics of a company. Next one, please. What are the deliverables of AMP? There are a lot of deliverables. I have listed quite a few. A comprehensive tool for documenting specific strategic goals. What are the performance target? This is an important thing. What is the performance target for an individual asset group? For example, a transformer. It should never fail for next 2 years. That may be one target. For a generator, for example, it has to be able to generate maximum generation for say 100 hours continuously. That can be one of the targets. So there are a lot of targets for a company. So we can say specify such targets for each class of equipment or individual equipment. We can do that. It also helps to form the basis for close monitoring of the key performance indicators of individual assets as well as overall operation objectives. It also, this asset management plan can feed into annual reports, because annual report would contain how much cost is managed, how incurred, and all of that. That information can be drawn from asset management plan. In situations of this is another important issue. If there is a regulatory obligation for the company to behave in a certain way, if unfortunately there is some mishap or somebody external customer, he puts a case on the company can make use of this asset management to prove to the regulator that they have discharged all their responsibilities to the best of their ability, and so that may help they reduce the complications of any liability issues. Next one, please. Again, these are the deliverables. If you can go through at your own time. May I submit here that I shall be very happy to interact with any of you or the larger team if there is a need at a one-to-one basis also. What does a typical AMP that was there? See, this is a large power transformer. You can, okay, there are a lot of issues. They have listed around 11 points as to what does asset management plan may really involve. I have done this. So that's what I took it from my own experience. Yeah, let's go to the picture, please. I think you can go through these things. That's fine. This is a large power transformer. You can see how complex it is. It's connected to the transmission line. So it has to be carefully managed, operated. The electric shock is the major issue. There can be inflammable objects also. This transformer oil is a highly inflammable material. So it has to be managed. This is one transformer. There can be another transformer by the side. And normally they will put a wall there, concrete wall, in order to protect one equipment from the mishaps of the other equipment. So these are all issues. There is a oil transmission units, pumps, then regulators, and etc. Next one, please. This is a closer view of another huge power transformer. This is a three-phase transformer. There can be a bank of single-phase transformers also. Next one, please. This is a typical the substation where you can see number of transformer, a large substation, so you can understand the importance of careful maintenance and operation procedures, because they're all charged equipment, and we have to operate carefully in order not to get electrocuted and not to allow another safe, healthy equipment to be protected from this. That's why there is a minimum gap between two operating equipment. There can also be a wall which can protect fire mishaps spreading from one equipment to another. You can see this is a small part of a substation. There are so many equipment here. All of them require certain care. Next one, please. This is a group of hydro power lines in a small geographical area. I wanted to show that these are all complex ones, because this transformer transmission line is designed such a way that even if it falls, it should not prevent the other line to be from damaging. So number of this is very common in dense population countries and all of that. Next one. This is actually a transmit, this small pole local distribution. This is the 11 kV line which brings power to our houses. You can see you might have seen a small transformer, pole mounted transformer very close to your street that reduces the voltage from 11,000 to say 220 volts of necessary for a house. So this is also, as you can see, how they are trying to optimize. There is a street light here. There is also seems to be a communication line here. At the top is 11 kV line. So this is a complex situation. It requires careful asset management plan. Next one, please. This is again another scenario of only LT line. This is not transmission line. This is low voltage line going side by side because of the heavy density of load. Next one. See, this is another picture of this is what I meant. Pole mounted transformer. These transformers are mounted on a pole. These are for lower voltages from 11,000 to lower distribution voltage. They are not very heavy. They are not huge. So they can be mounted on the transformer to reduce the capacity of the, cost of the entire thing. See, you can this single transmission pole has so many insulators, lines, transformers, connections, jumpers, etc. So yeah, next one. This is another substation. Is these transformers are not shown here? See, this can be shown. Yeah, this is only basically these are called as base, which is only to switch off, switch on. Next one, please. Next one. Yeah, this gives you an aerial view of what a substation looks like. At the extreme left, you have transmission towers, which brings and connects it to the external world. There is some control room, a concrete building, which has all monitoring equipment and the layout of the equipment. So this is a large overview of a substation, very complicated. So it requires a good asset management policy and asset management plan and a procedure to operate and keep it at the lowest cost and highest reliability. Next one, please. I think I'm yeah, basically this is what I wanted to share with you. I'm sorry I have seemed to have ran up to very high speed, but I wanted to expose you to various issues. So in case there is a need, we can always discuss. Thank you very much. If there are any questions, I shall be more than happy to try my best to respond.
Yeah, it's a kind of a general question, maybe not uh, directly related to your topic. Of course, asset management is involved there. Because today we are seeing, especially countries like Australia, they're totally moving away from the fossil fuels like coal and moving into solar, wind, and the renewables. Uh, are these going to really, I mean, the energy, there should be an energy mix in the sense that reducing fossil fuels to a minimum and then having the solar, wind, and renewables in place, because that's what we would want from the climate change, environment issues. So, what is your opinion on this?
Thank you very much, Dr. Pai. This was an issue which I'm very much interested. I'm working on that. During last 20, 25 years, I'm working on that. So, as Dr. Pai has mentioned, moving away from fossil fuels has become a necessity. It's not an option anymore. The sooner we go towards that, it will be better for the whole world from climate change perspective. And even if we don't care, and as our politicians are, they don't care about what's happening with the climate change at the global perspective. These coal power plants have huge impact on the local environment, local water pollution. They consume a lot of water. They end up polluting the soil. Air pollution is very high in North India, Delhi area, because they are surrounded by large number of coal power plants. So multiple problems are there, and coal mining also has a limited value. So once a mine is completed, then what do? So they have to borrow it from a longer distance. So fossil fuels are no more, and we know they are all finite in their resources, the national level, natural resources level. So we have to The earlier, the better. There is I am convinced there is absolutely no option at all there. We have to move away from that. The question is when. So the option here is to go for renewable energy sources like solar and wind and biomass and other things. But even there is a huge impact if we go for large size projects, because a large size solar project, even in a desert, it not only occupies a lot of area there, it requires a dedicated transmission line. It requires a certain quantity of water to clean the panels. So they all have environmental impacts one way or the other. And the cost also is high. They may talk about economically viable option is to have a large power plant, large solar size, because it will bring down the cost, but it may bring down the capital cost. But what about the operation cost? What about the ecological cost? So I'm a strong advocate of distributed type of renewable energy sources such as rooftop solar, small size wind turbines, community waste biomass and all that. What happens is we have a tremendous potential. India, as a tropical country, has a tremendous potential in these three areas. So one estimation say that if we utilize the solar energy that impinges on the surface of the earth of land of our own country, that is more than enough to meet our total energy needs, not electricity needs. If you convert all energy requirements into electrical units, the amount of solar energy that is available to us to be made use of is something like 5,000 trillion units per year. That is many thousand times more than what our total demand of energy now. So that is one way to go. If we have only distributed energy sources, then we don't require large substations, we don't require heavy power equipment, heavy transmission lines that won't occupy any agricultural land, forest land. They won't require a lot of water. For example, I have a solar photovoltaic on top of my house. I have exported more, 3 times more energy than I have ever imported from the grid. And how much water I use it for cleaning? I don't use much water because I use the cloth and make it moist and clean it. But if you have a large solar power park, you require water to clean it, forced water or forced rain. So there are issues. So, but as far as asset management policy itself is concerned, it will be similar. So I have to apply the same philosophy at my own rooftop panel. Of course, there is no condition monitoring, there is no reliability centered maintenance, there is no TQM because I don't have a control on that. But while buying the equipment, I make sure that they have met certain standards and I maintain them. So I think we will go towards this instead of large size power projects, we'll go for distributed energy sources. That is catching up all over the world. Australia is a leader in that. They have already done a lot of innovations. So I think that's the way to go. The earlier we go for that, it is good for everybody, entire country and the entire planet. Did I
Thank,
respond to your question,
yeah,
Raghuveer?
thank you. Thank you.
Are there any other questions? I can relate
So
to you
in
only
that
one of
case,
my.
there are no more questions. Sorry,
I,
Uday sir,
I
yeah,
can just a few
yeah, please
comments
go ahead.
only about the renewable energy. I see in Sweden actually there is a movement against the wind power now. They don't want people wind power turbines around their area. There's a huge movement. The people say that it changes the ecological, as you mentioned, the ecological balance in the nature. 10 megahertz, it's bad for the animals and for the different type of microbes and all. That's the one big challenge. Secondly, for solar panel also, the resistance is growing here quite a lot. People say the disposal problem of the solar panel will be a big issue. Third, for the wind turbines and all, rare earth mineral used for the magnets and all. And total, all around the world, I was reading a report about some pounds of active nuclear waste is being generated indirectly. So people should have a bigger picture of the things. So there are both, as you say, the people are supporting. So almost wind power is a big resistance there from the community. They don't want any wind power turbines. That's one. Solar panel, Sudan is not having much sun, so that has not become an issue. But China, when you travel from Beijing to Shanghai, like a conference, I'm amazed. I have traveled many times that area. And I see almost most of the houses, villages are have solar panel. And then I was talking to Shanghai. They say that the big issue is the recycling of those solar panels, maintenance of the solar panels. So, there are many problems are coming, this renewable energy and all. And so earlier we were much focused on the renewable energy, how to use the fossilized energy and all in a better way. That is also now being debated. So there, as you said correctly, that we have to have balance between all those things. So this is one
Yeah.
comment. Secondly, the German software that is SAP actually, system application product. SAP
Yes,
is
yes,
the
SAP, correct.
it's being used everywhere. So that's the okay. That's some of the observation I had.
Yeah, thank you, Mr. Uday Kumar. May I just respond to those issues?
Yeah.
What I would like to emphasize is that any technology, whether it is renewable, fossil, nuclear, hydropower, they
Mhm.
have their own impact on the environment, either directly, indirectly. The question here is, what do we do? Which technology is impacting us more? Which
Yep.
technology will minimize such impact? That is a careful decision. The entire society, human society, has to take it into account. As far as the pollution or the waste management of solar panels is concerned, may I say the pollution, there is pollution, I agree, but let's remember there are two things. One here, if it is a coal power plant, the pollution is not controlled there. It goes into the thin air and it gets spread over all over the country. Okay, but in case of a solar panel on top of my house, there is a pollution linked to that panel, but that pollution is in a given place where it was mined. So it is possible for human beings to manage it or control it or reduce it. Let us also remember that solar panel efficiency is growing every year. It's going up. So the total number of solar panel in order to meet all our demand may come down in another 20-30 years. It is coming down already. For example, when I started way back in 2009, the maximum capacity of solar panel for residential use was only around 80 or 100 watts per panel. Now it has gone to 500 watts. So efficiency has improved. So the pollution problem can come down if you manage it. And if there is a provision, I'm already reading article that Japan and other countries, they are already successfully managing to recycle around 95% of the material used in old panel for the manufacturing of a new panel. So that if that is extended, if it is further improved, then that can reduce the total amount of waste. Now, the waste, there are two things. One is, if it is a distributed waste, there is not much you can do. So you can't get it back from the air. But if it is a localized pollution, for example, in a power plant, then you can withdraw that, contain that, minimize that. And wind is concerned, probably what Mr. Uday Kumar was alluding to, are all heavy size wind turbines, say 50, 60 meters and all that. They are known to be impacting the path of the flight birds. Okay, that's fine. But if you go to a distributed type of minor, medium size, and say small size wind turbines, which can be installed on a rooftop, there the impact will be minimal. So these two are there. Then there is biomass. Biomass, we have large biomass because being an agricultural country. At all communities, we have a lot of biomass. We can use that. My submission, my conviction is that among various also options available to us, we have to take a holistic approach to the particular technology which is of use to us, and then make the
I
best
fully
effort to
agree.
minimize.
Yeah. Yeah. Actually, yeah, ecology. That we have to take a big picture and do the things. Yep.
So this is a never-ending process, as we all appreciate. Asset management plan, asset management philosophy, and applying that to the larger technology, and all of that is this is a never expand, never stopping, because we keep on improving. That there are new challenges coming up, and new challenges are being addressed. For example, battery. I can tell you about the battery. Energy storage batteries have a major role in future. Okay. Now, initially when we started, the cost of the battery was very heavy, and lithium was a major issue there. Lithium is a limited resource and all of that. What they have done is they have gone for different conducting materials. So, for example, sodium especially. So that they say has considerably brought down the cost of that, and the cost of maintenance or recycling or pollution management and all that. It has come down considerably. As we can all imagine, Dr. Pai is from MIT, which is an premier engineering institute. The continuously research is going on. So we are trying to find out more materials, improve the efficiency, reduce the pollution. This is a continuous process. A society has to define what is the demand. Does it really look for continuing to have the impacts of climate change, or do all that is possible to minimize that? That is a decision we have to take. Thank you.
Okay, in case there are no more questions, then I'll request Dr. Ganesh to give vote of thanks.
It appears Dr. Ganesh has muted. So he may be talking, but we can't hear him. Is it possible?
Yeah, he's back.
Am I audible?
Yeah, yeah.
Yeah. Good afternoon, everyone. It's my privilege and pleasure to propose vote of thanks for today's insightful webinar on effective application of asset management principles to reduce overall cost and improve reliability in the electric power sector. On the behalf of Asset Management Society India, I extend our heartfelt gratitude to our distinguished speaker, Mr. Shankar Sharma, Power and Climate Policy Analyst, for sharing his deep insights drawn from over 4 decades of experience across India, New Zealand, and Australia. Your talk has provided us with a comprehensive understanding of how asset management principles can shape sustainable and reliable power sector operations. Our sincere thanks to Dr. Raghuveer Pai, President of AMSI, and Professor H.K. Mishra, Secretary of AMSI, for their continued guidance and leadership in steering this webinar series. I also thank Dr. Girish H. for opening today's session with his warm welcome, and Colonel Sunil Yadav for his thoughtful introduction of the speaker. A special word of appreciation goes to all the participants from academia, industry, and research who joined us today and contributed to making this session interactive and enriching. Last but not least, our thanks to the organizing team behind the scenes for their meticulous planning and smooth coordination of today's event. Thank you all once again for being part of this AMSI initiative. We look forward to your continued participation in our upcoming webinars under the theme of the future of engineering asset management. Have a wonderful day ahead. Thank you.
Thank you, Dr. Ganesh, for the vote of thanks.